All right. Welcome to Math Factory, where we take things apart, we analyze them. Today we're going to be talking about differentiating inverse functions. We have this really cool function, y equals inverse tangent of z divided by 1 minus z squared. And we're going to use a technique involving trigonometric substitutions that are going to help us solve this problem. So the first thing I want you to do is, when you look at this problem, I want you to consider first a relationship relating tangent of y to z divided by 1 minus z squared. So we know that tangent is the opposite side of an angle divided by the adjacent side. And from that, we can solve for the missing side of the triangle using Pythagorean theorem. And from all of that, we end up with the square root of z squared plus 1 minus z squared to the power of 2. The variable for a was z, and the variable for b was 1 minus z squared to the power of 2. Now we're going to create a relationship relating theta to z over 1 minus z squared. And we're equating them. And I go back to my original problem, and I input theta in place of z minus z squared. Now remember, we're differentiating with respect to z. Now, first thing was I differentiate the left side. So the derivative of tangent was secant squared y, the dy dt, and the derivative of theta with respect to z is d theta dz. Solving for dy dz, I get a relationship 1 divided by secant squared y multiplied by d theta dz. And we have to replace all of that information. So the first things first, I'm going to differentiate theta. Theta equals z divided by 1 minus z squared. Using the quotient rule, I have u is z and v is 1 minus z squared. Therefore, v prime would be minus 2z and u prime is 1. Using the quotient rule, and remembering that after the minus sign in the numerator, I put a bracket in there to keep all my variables together and keep my work organized. Using algebra, I simplify down to 1 plus z squared divided by 1 minus z squared to the power of 2. Now let's return back to our problem. dy dz equals 1 over secant squared y times d theta dz. This is where I get my relationship from the triangle, because secant y was square root of z squared plus quantity 1 minus z squared to the power of 2, all under the square root time divided by 1 minus z squared. And I replace d theta dz with 1 plus z squared divided by 1 minus z squared to the power of 2. Now we're talking about secant squared, so now the square root is gone, and the piece of information in the denominator has a power of 2 times 1 plus z squared divided by 1 minus z squared to the power quantity 2. Now, this information on the left side Once we simplify, we'll cancel with 1 minus z squared to the power of 2 on the right side in the denominator. And you can see how I've highlighted them in red to show you that they cancel out. Now, I'm left with 1 plus z squared divided by z squared plus parentheses 1 minus z squared close parentheses to the power of 2. And here I'm going to use a little algebra. I'm going to FOIL it out. I keep all my information together in brackets. Minus z squared is minus 2z squared plus z to the 4th. Relating it all out, removing the brackets. Now I can add up like terms, and there's only one, z squared minus 2z squared. Leaves me with a minus z squared, and that's my concluding answer. Sometimes it's good to write it out in descending order of exponents. That's fine. Now I want you to practice this problem over again from beginning to end. Work out the little details separately on different sheets of paper and then put it all together like a puzzle and see if you can come up with this final conclusion. So let's go back to the top. And I'm going to allow you an opportunity to view this from the beginning. We had our inverse function. We created a triangle, used Pythagorean theorem. I put a substitution piece called theta. I differentiated both sides. Now I differentiated my theta with respect to z. Use some algebra. Now I'm back to the problem, and I'm replacing all that information for my triangle and from d theta dz. Now using algebra, I multiply, divide by the reciprocal, cancel, and now I am using basic algebra to solve the problem. To simplify it out, I just write it in descending order of exponents. All right. So I hope you all enjoyed this presentation for the Math Factory.